Okay, so let's check we've got the equipment. We've got here a resistor. We should have 4 of those. So there they are there, and they're all 10 ohms. We've got a cell, and inside there's a resistor that you can't get to. So inside this battery pack here, there's a resistor inside that. And these resistors here are going to go into these clips. And over here I've got an ammeter up there. You can see what settings it's on. Okay, so first step, we need to set up the circuit. Connect the circuit shown in figure 1.1. So first step will go from the one end of the cell around to the ammeter. So cell to ammeter connected, and then from the ammeter we go to the resistor. So here's the other wire for the ammeter, and we connect it to one end of our resistor, and then from the other end of the resistor we go around to a switch, but the switch will just be pulling the plug in and out. Okay, so we effectively go around from the resistor back around to the battery again. So here's the other side of the battery with this cord, and we go to our resistor. And what I won't connect up the resistor as a way of turning it on and off. Now, first step, close the switch S and record the value of current I and the resistor R. So we need to put a resistor in. Okay, so we've put the resistor in. And so we now write down, record the value of the current I and the resistance R. So we've got one resistor, so that must be 10 ohms. And then we've got a current here. So we put that down. Okay. Next page. What I've done on this page, I've set it up with a little table, and we'll see if we'll fill it in first. So it says the combined resistance of resistors in series are R equals R1 plus R2. The combined resistance of resistors in parallel is 1 over R equals 1 over R1 plus 1 over R2. And then we've got change the value of R by using different combinations of the 10 ohm resistors and repeat until you have 6 sets of readings for I and R. You may need to twist the ends of resistors together when joining them. Include values of 1 over I in your table. Okay, so first step, let's put in the column heading for resistance. Okay, and then we've got a column heading for current. And then we'll do the average current. And then we need to have 1 over I. Okay, now we'll start off. We've actually done one resistor already, haven't we? A 10 ohm resistor, and then we've got a current for that one from the last one. Okay, and we can put that all in. Now the next step, we'll try a different combination of resistors. The two side by side there. So that means they're resistors in series, so I'll put in the value then. Resistors in series means we just add them, so that will be 20. Okay, and then we'll look up at the current there. It's 50. Oh, it's changing a bit. So let's say 54.7. Have a guess, and then write that down. Okay, now we'll try a different combination. Okay, now I've got 3 side by side there. 3 side by side. So that must make it 30. Okay, and let's read our data there. So about 39.6. And we put it over there, 39.6. Okay, let's try a different combination. Okay, so I've now joined them in line, as you can see, and so that means they must be parallel. So for parallel it will be 1 over r equals 1 over 10 plus 1 over 10 makes 2 over 10. Okay, so that gives me a parallel resistance then of 1 over 5. And then I grab my value up there, 26.52. Put it down here, 26.52. Okay, let's go do one more, which is good. Now we'll add one more. Okay, I've now got 3 of them in a line there, so let's work that one out. So 1 over r equals 1 over 10 plus 1 over 10 plus 1 over 10. So that makes 3 over 10. That's what 1 over r is. So r is then equal to 10 over 3. So let's say 3.33 recurring. So let's do 3.333 recurring. Now what is our current? Looks to be about 22.36. We write it in there, 22.36. Okay, what I might do is just do the first one in the next column. I'm going to use the calculator. So we can go 1 divided by 48.7, and we get 0.020534. So 0.020534. And then we'll just imagine we've done the rest. So remember, this is not a good practical, there are mistakes. Please find them. B, all we have is we have a funnel, retort stand, scales, stopwatch, and 3 beakers, A, B and blank. Okay, A and B have salt in it, and the other one's got nothing. In this question you will investigate how the mass flow rate of salt passing through the hole in the funnel depends on the mass of the salt in the funnel. You're supplied with 2 small containers holding salt in an empty container. The mass of the salt in container A is MA and the mass of the salt in container B is MB. Use a top-hand balance to determine MA and B. So let's just measure MA. And we get 80.2 grams. So MA equals 80.2 grams. And now we'll try MB. And we get 109.1 grams. So MB equals 109.1 grams. Okay, so that's all the data we need to collect on this page. So I'm only collecting the data. Okay. The second question, we've got a setup here of a retort stand and funnel and 3 beakers, A, B and blank, and looking at the diagram and the instructions, it tells you to put the empty container under the funnel. Now it says place your finger over the hole at the bottom of the funnel and pour the salt from container A into the funnel. Move your finger away from the hole and at the same time start the stopwatch. Make and record measurements to find the time TA for all the salt to leave the funnel. Okay, so we'll do that. So we're using this for container A. I'm going to pour that into there, put my finger on the bottom. Okay, so we've got the salt for A in there. Okay, and as I take my finger off, I'll start the timer. Oh, we got exactly 11.00 seconds. So we'll write that down. 11.00 seconds. Okay, now let's have a look. Repeat the procedure for the salt in container B. Okay, so there's B. Now we'll repeat the procedure. Okay, so now we're going to do this for container B. Okay, so B's in here, and so let's go. And we get 24.44 seconds. Now what we might do, we might try this twice. Okay, so I've put B back into the funnel and we'll try this again. Okay, so we get 23.25 seconds. So we'll write that down. Yeah, you just make the percentage uncertainty. I'm not going to do that. I'm just going to do the actual experimental work.